Welcome to this explainer. Let's step straight onto the flight deck of a Bombardier Q400 to master the precise, rule-based logic of its flight management system. If you've ever wondered exactly how the computers on this incredible aircraft think during the absolute most critical phases of flight, well, you're in the right place. Today, we're breaking down the FMS approach logic, translating those dense technical manuals into clear, actionable, everyday understanding.
Okay, here's our pre-flight briefing agenda for today. 1. Approach guidance basics. 2. Activating approach mode. 3. Waypoint sequencing rules. 4. Missed approaches and TOGA. And 5. FMS sync mode explained. Let's get right to it. Section 1. Approach guidance basics. Setting up the descent.
So as your Q400 begins its approach towards the runway, it's absolutely vital to get the core design philosophy of the system. The big takeaway here, while the system perfectly stabilizes your descent path, it is never going to automatically level off at the minimum descent altitude, or MDA, for you. Why? Well, because the MDA actually varies depending on the specific approach speed category of the aircraft. Since that variable exists, the FMS leaves the responsibility squarely on you, the pilot. If you don't have visual contact with the runway environment when you hit that minimum altitude, it is entirely on you to terminate that descent manually.
Now, as you ride that stabilized descent down, where exactly is the FMS aiming? The navigation database altitudes are strictly designed to provide a threshold crossing height of just 30 to 50 feet directly over the runway's touchdown zone. It's like a highly precise, mathematically calculated thread that the system is pulling you through, literally right down to the pavement.
Moving down the sequence, let's jump into Section 2, Activating Approach Mode, the data feed. Let's look at exactly what happens on your instruments when you transition into the approach, and that FMS APPR annunciator finally lights up on the flight deck. The second that approach mode is active, boom, the system instantly feeds these 6 critical pieces of flight guidance data to your Q400 instruments. You're getting your bearing to the active TO waypoint, your desired inbound course, and crucially, your cross-track error. This lateral deviation actually acts a lot like a localizer. A full 2-dot deflection means you're off course by 2 degrees, or up to 350 feet. It also feeds your glide slope, where a full 2-dot vertical deviation equals a 0.7-degree angular error. And finally, it gives you your lateral and vertical valid flags, basically letting you know the data is trustworthy. To make sense of those validity flags quickly in the heat of the moment, I want you to memorize this really simple trick. Think lateral equals navigating left and right, while vertical equals glide slope sliding up and down. When the lateral output is valid and safe to use, your nav flag just drops out of view. When the vertical output is valid, the GS or glide slope flag drops out of view. It's simple, reliable, and super easy to recall when you're under pressure.
And this brilliantly illustrates our first major safety rule. You must never fly any approach under instrument flight rules unless the FMS is actively in approach mode. You, as the pilot, have to physically select either ARM APPR or ACT APPR at some point prior to the final approach segment. Honestly, if you don't do that, you aren't flying a true IFL approach according to the aircraft's logic.
All right, Section 3, Waypoint Sequencing Rules, the strict boundaries.
You see, the FMS demands incredibly rigid mathematical parameters before it's going to sequence to the next waypoint. The computer doesn't guess, it calculates. To memorize this effortlessly, just remember the trick, high five for 80 degrees. Regardless of where the aircraft physically is, the TO waypoint is going to stubbornly remain the exact same until you are absolutely within 5 nautical miles of the inbound course and you have an intercept track within 80 degrees of that course. If you're outside those parameters, the TO waypoint simply won't change and your HSI will just show a from flag if you've already flown past it. So, high five for 80 degrees keeps your sequence moving.
Furthermore, the FMS strictly categorizes the complexity of what you're actually flying. We call this next concept the 6 degrees of separation rule, and this instantly defines an approach as an advanced approach in the nav database. If there's a course change between the approach label and the end of approach of more than 6 degrees, or if it contains a precision arc leg, the system automatically flags it as advanced.
Now for Section 4, Missed Approaches and TOGA, Breaking the Sequence. Aviation is all about managing the what-ifs, right? And the Q400's FMS has highly specific logic for when you need to hit those takeoff/go-around, or TOGA, buttons. Thanks to a software enhancement, specifically software configuration number 1000.6 and later, the system's TOGA input processing is strictly governed.
The system is only going to react to TOGA or go-around inputs when a missed approach is actually available to the FMS. Plus, if you manually modify, insert, or delete any part of your programmed approach, even if you just delete the approach name, the system will strictly cancel approach mode altogether. It absolutely requires an intact, valid missed approach procedure to function correctly.
So, if a missed approach is required in the Q400, you have to meticulously follow 3 exact steps to safely transition your guidance. First, you must select Missed APPR on your nav page 1 or hit TOGA. This crucial action removes the gap from the lateral guidance leg set. Second, the approach will just naturally continue until the end of approach waypoint is overflown. And finally, the legs will sequence normally, giving you precise guidance directly to the missed approach holding fix.
But listen, be incredibly careful here. This is a massive trap for the unwary. Canceling and reactivating the approach too soon while you're climbing straight out during a go-around will instantly satisfy the auto-sequencing rules we talked about earlier. Remember the high five for 80 degrees trick? Well, climbing straight out literally means your track equals the approach course, and your cross track is essentially 0. So hitting activate early will completely wipe out your flight plan legs in seconds. It just rapidly sequences through all the approach waypoints while you're just trying to safely climb away.
Let's wrap things up with Section 5, FMS Sync Mode Explained, the Digital Co-Pilots. Let's look under the hood at how the 2 independent FMS computers on the Q400 actually talk to each other during all these dynamic flight events. I want you to think of the primary FMS and the offsite FMS as co-pilots trying to read from the exact same script. They need to be perfectly synchronized. When configured for an SBAS approach, manual selection of the level of service is synced between them. But if they hit a snag, like manual selection being available on one FMS but not the receiving one, they instantly drop their sync. They'll flash an FMS sync loss message, and from that point forward, they stubbornly work completely independently.
The digital rulebook governing their relationship is incredibly strict. Depending on the exact sequence of events, the systems will either output S to process and maintain sync, I to ignore sync and transition to independent mode, or DN to simply do nothing. For example, if the offsite FMS is already active and you try to arm or activate it again, it realizes it's redundant and just executes a do nothing. But if the approach is not armed and you suddenly hit missed approach, it throws an I, instantly breaking sync and going independent.
Understanding this unforgiving sequential logic is the absolute key to flight safety and true mastery of the Bombardier Q400. You are managing a highly complex, logical brain up there. So, the next time you strap into the flight deck and unexpected weather forces you to alter your approach path, ask yourself, do you truly know what your FMS is doing behind the glass? Is it syncing, ignoring you, or silently doing nothing? Keep learning, keep flying safe, and thanks for joining me on this explainer.